Well, I'm just asking, why do you think a lot of people would write this? And we'll talk about why it's wrong in a second.
So it's times two.
Oh, because they're
And then they did n times the square.
Right, well, so not n times squared, but they squared the n
So it
and
needs
they
to
squared
be-
the 2.
It needs to be 2
Right.
n instead of n to the second.
Well, I'm just pointing out what a lot of students want to do here is they square the n and they square the 2. And that's all that they do. But we talked about it last week. If you're squaring n plus 2, what do you actually need to do?
Shouldn't it be n2 plus 2 and 2?
Say that one more time.
Oh, you're doing
N squared plus 2n, then plus 2.
Not quite. So this is why you need to write this step first.
plus 4.
So
Plus,
remember, if I'm squaring, what does that really mean?
yeah, 'cause you're multiplying.
You need to write it as literally what it means. That is the same thing as squaring something. I'm multiplying it by itself. Okay? So for part C, you need to write that first. You need to show the n plus 2 times n plus 2. Okay? From there, Jaden, what property could we use to simplify this expression? What was your question, Cameron? I'll get back to what you said.
Wait, so how did you just separate them instead of squaring both of them?
Well, it's not squaring both of it. You're just squaring this. But if I have 3 squared, isn't that the same thing as 3 times 3? So I'm literally just multiplying this thing by itself. Right? Does that make sense? But, so Jaden said that we could distribute. CD, what do you think about that idea? Yeah? So then what do I need to multiply this n by right here?
Times n and then times 2.
So n needs to be multiplied by n and n needs to be multiplied by 2? Okay? So LaShane, what is n times n?
Oh, you said n, yeah.
N times n. Just n? So remember, when we multiply something by itself, that's n squared, right? Okay? Jeremiah, what would n times this 2 be? Jeremiah, you're not even giving yourself a chance. What is n times 2? Okay, you better pay attention because I'm going to come back to you on the next one. Gracie, what did you say it was? N times 2?
Oh,
2n. I'm literally just multiplying the 2 in the end. Yes, Jada?
That equation is Maureen's.
I started with Maureen's, right? And then I'm ending with Matthew's. We're trying to show that they're equivalent.
I don't like money.
Two
She makes
Okay.
n plus 1 go.
Say again?
Where'd the 2n plus 1 go? Yeah, where's the rest of the equation?
I thought Maureen's was n plus 2 squared. Oh, thank you.
Subtract 2.
I just missed part of
I
it.
think we're doing Matthews for a minute there.
N plus 1 is what it's supposed to be? That's my fault. I just misread it. Oh, I was thinking about the homework problem. That's my bad. Thank you for catching that. Okay, so Jeremiah, we've distributed the n times n plus 2. What am I going to do with this 2 right here?
We distribute.
He didn't say Colin.
Jeremiah, what did Colin say?
I thought you just asking
He said
Jeremiah.
I said Jeremiah. He said distribute. So that means I'm going to take this 2 and multiply it by n. Am I going to stop there? It's just 2 times n? That's how I distribute it?
I don't know, you gotta do 2 and 2.
I'm going to do it to the 2 as well. So Jeremiah, this is your last one. I know you can do this one. No, you're good. I wasn't asking Jeremiah that question. Jeremiah, what is 2 times n?
Which part, are we the n2 plus 2n or are we the one flip?
We're right here. Jeremiah, it is literally 2 times n. You can literally say that thing. What did I just say?
It'd be the same as the other one, like the one I just said.
So, Gracie, what did you say when it was n times 2?
It was 2 then.
2n. So Jeremiah, what is 2 times n? I can't help you if you're not gonna try, bro. Like, come on. And then what's 2 times 2? 4. Oh, and then Matthew's is not plus 4, it's plus 2. Yeah.
Wait, so are we on Maureen or Matthews?
Remember, what are we trying to do? We're trying to
Make
show
sure
they
they're
are
equivalent.
equivalent, right? So just like I distributed n plus 2 times n plus 2, I'm also going to distribute over here. So minus 2n minus 2. Any like terms?
2n plus 2n.
So 2n plus 2n. Anything else?
Wait, can you subtract 2 and 2?
So I have 2n plus 2n minus 2n. What would I be left with? 2n. There we go. I've already got the n squared. The 2n plus 2n minus 2n, that's what gives me the plus 2n. And then any other like terms?
4 and 2. And negative
4 minus 2 is,
2.
it gives me that plus 2. So are they equivalent?
Yeah.
Yeah, we got exactly the same thing. Any questions from there?
Okay.
On the test?
4 and
The ability to simplify expressions and check to see if they're equivalent, yes. Not on the understanding check tomorrow, though. Yeah, we got an understanding check.
Maureen's all
So
in.
it's probably like this.
So the understanding check, the main things are you will have to identify linear versus exponential versus quadratic functions, and then write linear and exponential equations.
It's like showing us if it's a graph.
You have rails on this?
Is these square things gonna be on the plan?
What? How is the, I think I can do a graph. Where did the 4 go?
It's like I know you.
What
Like, why
for?
is it pointing at a 2?
Yeah, I know.
Because it's.
4
4 subtract 2.
minus this 2 gave me that plus 2.
Okay. And where did that minus 2n go to?
What's 2n plus 2n?
4n.
Minus 2n?
2n. Okay.
I just went ahead and simplified those like terms. That's why I color coordinated it as I put the blue pieces together, pointed it to this plus 2n, and the orange pieces together. While Lexi's going ahead and finishing that up, go ahead and grab a MacBook. One person from each group come grab MacBooks for your group.
Yeah, I did the equation, right? And then I was like, what do I even plug into? Yeah. But my other. Here's a one time about but ends where you can start on my phone and like here's.
Alright, while you are grabbing the laptops and logging in, let's go ahead and talk about the objectives. So, really quickly, and you'll see this once you get into the activity, there are, well, actually, let's start here. There are 3 different equations for a line. Can anyone give me one of those equations for a line? Y equals mx plus b, that is one. That is known as the what? Slope, intercept. Okay. Does anyone know any of the other equations of a line?
The change of x over the change of y, is that something?
So change in y divided by change in x is slope.
A plus bx.
I think you're thinking,
That's not a line.
oh, a plus bx, that's still slope intercept.
Okay.
Yeah. It's just a different format for slope intercepts. There is also this one, which we haven't hit on this one at all this year, but you should have covered it in Algebra 1. This is known as the standard form. Yes, ma'am.
Some kids still like.
If someone is still logged in, just turn it off and turn it back on, and it'll allow you to log in.
Can I get my
But
phone so I can?
go ahead and log in.
Can I get my phone to get my password? Or did we change our passwords
Yeah, I
already?
forgot the new password's weird. The
It
other one
is.
I could figure it out.
It's hard to remember.
It's like capital S, lowercase j,
I know.
period, slash. I'm
You
like-
you gotta know it.
No, wait,
But
but
go
question,
grab your
when we
phone.
changed our thing, our email thing for, the, exam, not the exams, the ACT, yeah, when we have to turn in the stuff, is that the new password? Or-
Yes.
I didn't know mine was the same one.
Huh? You see in the top right, it's doing that thing. It's gotta be a little circular thing, but you don't need to log into that right now. We're gonna use the computers. So log into your computer. If you need to grab your phone to look at the password, you can do that.
That's the wrong password.
Okay?
Okay, yeah, I need it. If they would've just made them normal, or like our lunch numbers or something, like keep them all the same.
It's for a security thing. I don't necessarily agree with it,
Like,
but
nobody trying to figure out your email. Like, really, what am I gonna do?
so we should be logging into our laptops.
It's only forever if you want mine.
Okay.
Did you think it was a lowercase l?
Yes, or a one.
Or a 1? Okay. I'll show you where to go once you get logged in. But what I need you to hear me on is this. These are 3 different equations of a line. We're only going to be focusing on one of those. We've only focused on slope intercept, but this is also known as standard. Does anyone remember the name of this right here?
It looks familiar, but.
So I will point this out. The x1 and the y1 would go together, creating a what?
Algebra 1.
You would have learned this in Algebra 1, but look, the x1 and y1 go together, creating what?
Oh,
I can't remember.
A point.
Point
So it's point slope form, okay? So we have slope intercept, we have point slope. It's your choice which one you use. If you remember your point slope, go for it, right? Point slope is actually, in a lot of situations, easier than the slope intercept because you have to have the y-intercept for slope intercept. But my point is this, all 3 of these are equivalent. You can write any equation of a line or any line in one of these 3 forms, okay? And so we're going to look at something similar with quadratics, that there are 3 different equations of a quadratic function. There's the vertex form, there's the standard form, and then there's the factored form. And then we're going to use the different equations to identify features of that function even without a graph. The concavity, the vertex, the x-intercept, the y-intercept, and the axis of symmetry. So we're going to be looking for all of those pieces just based on the equation. We're going to start with the equation and the graph. But go to Desmos.com. Either log in or sign up in this top right-hand corner once you go to Desmos.com. Okay? We should already be logged into our computers. Let's try to get that.
Crazy about these, 0909.
No, you don't. You just stop there.
Oh. Okay, and then we have other password, that's.
Okay. So if you have never been on to Desmos before, sign up. You can use your TCSS email and that password so you just get used to using it more often. If you have a Gmail account, you can do that. Just make sure you know what your email and your password are. Make sure you put your name in there, first and last name, when you log in or sign up. You can change it under account settings. Just by having your first and last name, it makes things easier for both you and I. You can say again. If you have an Apple email, you can. If you have Gmail, you can sign with Google, or you can go to email address and you can use your TCSS email.
I accidentally pushed shift for it won't let me like look at your password while you're typing it, so I couldn't tell if I was shifting and do a question mark or shifting with a slash.
Yeah, I don't like that component of these Macs that you can't like
Like do the little
view-
eyeball and
eyeball
see
and
your,
view
yeah.
your thing. Okay, so once you are logged in, let me know if you're having trouble, but once you are logged in, go to student.desmos.com and type in this password, or you can just go to desmos.com and you put in the code when you scroll down, but desmos.com. Do you not know your email and password at all? Huh? Okay, so you need to get that so we can get logged into these.
Oh no, this is Barracuda. Is it supposed to go to Barracuda?
No,
Why
means
am
you
I-
had an error.
Isn't that the one that killed Nemo's family? Is it not? Was that not a Barracuda?
Yes, it was.
See, he knows what I'm talking about.
Have you ever done Desmos?
No.
So sign up. Whatever you want. Is everybody logged into the computers? Getting into Desmos?
Name or nickname?
Yeah, you can put the code in there, 4E4XC5.
My whole name.
Okay,
Password.
Is what's with you?
that's it.
Okay, I agree. I have my.
There we go.
And never save that.
So yeah, click here, go to desmos.com, and I'll get you caught up with everyone in a
What
second.
in the world is this? This is not math.
What?
Do we need to capitalize
It
the
is
code?
math. Hold on.
Hey, what's? No, it said, it started with A, B.
Okay,
Where'd the other one
Four
go?
E, 4XC5.
Okay, 4E4X.
So-
XC.
C5.
did you need I'll put the password back up in a second if you need it. Okay, to get everybody else started, right? So forms of quadratic equations. When you studied linear functions, there were three different equations. Slope-intercept form, y equals mx plus b. Point slope form, y equals m times x minus x1 plus y1, or you can do it this way. I'm not as big a fan of that format. And then standard form. Each of the values, not the variables, but the values, right? So the m, that was our slope, rise divided by run. B was the what? Y-intercept, right? So the b connected directly to something on the graph. Similarly, with point slope, x1 and y1, that was a point somewhere on the graph, right? The values connected to the graph in very specific ways. Right? So I talk about that a little bit here. But with quadratic functions, there are three different main equations too. These forms are the vertex form, y equals a times x minus h squared plus k. The standard form, y equals ax squared plus bx plus c. And the factored form, y equals a times x minus r1 times x minus r2. Throughout this exploration, your job is to determine how the different values in these equations connect to the graphs. Okay? So I know that looks like a lot, but that's what we're trying to do is figure out how does the a, the h, and the k in the vertex form connect to the graph. Okay? And so when you get in here, looking at the next slide, you'll notice like all it is a bunch of sliders. Adjust the value of a and observe what happens to the graph. So when you take the slider a and you move it around, what do you see happening to that graph?
It's getting thinner.
It goes up, and then it goes out, and then out.
And so there's some language that we should know to be able to talk about it. And then notice how it says record your observations on the next screen. And so you'll come here and I'll have a couple of questions. So you may need to go back to the previous screen to figure out what's happening. But describe how the graph of the parabola changes when the value of a is positive versus the value of A is negative, and when the value of A is between -1 and 1 versus less than -1 or greater than 1. We are trying to find patterns to understand how the A affects that graph.
So is A 2 points though, because every time you move it to 2 points, I move them.
No.
Well, which one is A?
A is, I will say this, A is not one of, first off, right now, you see how A is 1.4? Do we see how A is 1.4 right now?
Yeah.
Do you see 1.4 anywhere on the graph?
No.
No. So A is not necessarily a specific number on the graph, but it directly impacts things. Just like the M, that slope, is not a specific number on the graph, but it affects the line very heavily. So I just need you to figure out how is A affecting this function.
I know.
And Jeremiah, you still need the password to get in, right?
Okay, so on the line, A is on the line.
My A
So
is
1 point is right.
You'll, so remember, you have a slider right here, grab that slider and move it around.
Okay.
Right, so that's the whole point, is grab your slider and move it around to see what happens to the function.
So
I just need you to explore and discuss with your group as you find out what is happening.
So is A just a point on the, it looks like it's that, but
It's the line.
I know, because when you move it, it's only moving on the line and then the black
So
dot.
talk about it within your group. For those of us who still need to get in,
We're not worried.
There's your
about
password.
the black dot stuff right
I know, I'm past that, I know, I'm saying the,
Seriously?
red one.
now. Oh, yeah.
I'm saying like the black dot stays, and then when we move the red dot, it's going up and down the line. So if it's up here, then the curve goes up, if it's down here, the curve goes up. But what is it changing? I don't get what I'm supposed to be like. Did we answer this on
yeah, so
something?
go to Office 365 log in.
What?
Yeah,
Like
type it in there.
when it's value is
What did you, no, don't turn that off. Don't do that. You're just moving the A
I
around.
know, I've already done that, every answer I have is wrong.
What do you mean every answer you have is wrong?
Like I said, that the, the black one's staying there and the
Okay,
A.
look again and look at the next slide.
Right.
Describe how the graph of the parabola changes when the value of A is positive versus the value of A is negative. That's all I'm asking you to look at right now.
When it's negative, it goes.
Well, yeah, but that's, yeah.
That's what I'm looking
That's
for.
the same thing.
What's happening to the graph, but it's not the same thing. Use your,
I know, it's like so self-explanatory, I feel like it's too easy of an answer that you're asking for, like I didn't know that that's.
just when the value of A is positive, what is happening? So y'all are, you finished 3? Wait, hold on. On slide 2, just the value of A. That's all we're doing on this one.
The value of A is between negative
Nope, don't do that.
versus
Just grab
less
A,
than, oh.
move it around. Right, so when we change that value of A, what do we see the graph do? Okay, so what language could we more accurately use to describe what's happening there?
Or, what is our thing called, like, quadratic and A?
The smaller A gives.
So like, if I did that and it's giving me a red square, like I did it wrong. Wait, where's spell check?
The parabola moves over.
PARL.